Hola! We are going to explain about apply maximum and minimum. Before that, I want to introduce you our presenter. First one is myself, Farhan Azri Bahad Maikara Anwar. Okay, next, the second presenter is my boy, Abang Muhammad Amirul Haziq bin Abdul Latif. The third one is my great leader, Abang Muhammad Alif Hikmi bin Jasni. Last but not least, Abang Zulfatli bin Mukhtar.
The process of finding maximum or minimum values is using derivatives technique. What is derivatives technique? It is the idea to find the instantaneous rate of change of something. The process of finding derivatives is called differentiation. We have used derivatives to find maximums or minimums of function given by formulas. But it is very unlikely that someone will simply hand you a function and ask you to find its extreme values. Typically, someone will describe a problem and ask your help to maximize or minimize a quantity. For example, what is the largest volume of a package that the post office will accept? What is the quickest way to get from here to there? Or what is the least expensive way to accomplish some task? So let's take a look at our example.
Our group selected question 5. A rectangular storage container with an open top is have volume of 10 meter cubic. The length of its base twice the width. Material for base cost 10 ringgit per square meter. Material for a side cost 6 ringgit per square meter. Find the cost material for a cheaper size container. The question asks to find the cost of material for a cheaper size container. Before that, we need to know the keyword first. In the question stated that the rectangular storage container with an open top, then the length of its base is twice the width. Material for base cost 10 ringgit per square meter and 6 ringgit per square meter for a side cost.
So, we continue to how to solve. Step 1. Draw the diagram and use the info. So, first we must draw the diagram. So, this is the diagram. So, at the question, he informed the length is twice the width. The length is twice the width. So, represent it. And the length is 2x and the width is x. But he didn't inform for the height, so we can represent it any variable. So we represent it t to the height. So continue. At the question, he informed the volume is 10 meters cube. So we can write V equal to 10 m squared 10 m cube. So 10 equal to formula for volume is length multiply with width and multiply with height. So 2x multiply x and multiply t. So we get 2x squared t. And simplify it. So t equal to 5 over x squared. So continue to step 2. Find the area and replace the value. So area. So we can, as we know, this is a open rectangular storage container. So area, the first one is for the base. So 2x multiply with x. So 1 base 2x multiply with x plus to the left and right side, so 2. So because we got 2 left and right, so x multiply with t, x multiply with t, so plus with 2xt multiply with 2 because 2x multiply with t, 2 because we got front and back to the container. So 2x multiplied with x, we get 2x squared plus 2x plus 4x, and simplify, we get 2x squared plus 6xt. So replace the value of t we got before. So 2x squared plus 6x multiplied with 5 over x squared, and we get 2x squared plus 30 over x. So continue to step 3. Find the equation of cost. So from the equation area here, 2x squared plus 30 over x. So ni 2x squared plus 30 over x, and we know the first is for the base and the back is 30 over x for the side. So at the question he informed cost for the base is 10 ringgit and for the side is 6 ringgit. So multiply 2x squared multiply with 10, we get 20x squared. So for the side 30 over x multiply with 6, we get 180 over x. So this is the equation for the cost. So continue to step 4. So we must find the value of x and t. So from the equation cost, we get before ni. So 20x squared plus 180x power of negative 1. So we must do the first derivative. So we get 40x minus 180x power of negative 2. So bring down the negative 2, we get 40x minus 180 over x squared. So to find the value of x, so the equation must be equal to 10. So we get 10 equal to 0. So 0 equal to 40x minus 180 over x squared. So to hilangkan x squared, we must multiply all to x squared. So 0 multiply with x squared, we get 0. 40x multiply with x squared, we get 40x cubed. So 180 over x squared multiply with x squared, so habis, so we get 180. So bring 180 to the left and we get 40x cubed equal to 180. X cubed equal to 4.5. So we get x, value of x is equal to 1.65 meter. So to calculate the t, this is the equation we get at the volume before at the first. So t equal to 5 over x squared. So replace the value of x, we get before 1.65. So t equal to 1.84 meter. So to find the total cost, so we use the equation here, equation of cost. So replace the value of x, we get before value of x, so equal to 20 multiplied with the value of x, 1.65 square plus 180 over the value of x, 1.65. So here we get 54.45 and here we get 109.09, and the total cost is 163.54 ringgit Malaysia. And the last step 5, to know the cheapest cost, so we must using the second derivative. So from the first derivative, we get 40x minus 180 the power negative 2. So we use the second derivative, we get 40 plus 360x the power of negative 3. So as usual, bring down negative 3. So we get 40 plus 360 over x cubed. So replace the value of x we get before. So 40 plus 360 over 1.65, the value of x to power of 3, we get 120.14. The value is bigger than 10, so we get the smile graph. So here, this point is minimum, so we get the cheapest cost.
In conclusion, finding maximum and minimum values is an alternative for businesses to minimize costs and maximize profits. For example, from the question in this presentation, we can calculate the cheapest cost. The maximum and minimum values is called optimization, and it is normally used by industry work. This method also helps to minimize transportation time and use least amount of materials to make a particular object. That's all from me.